This was done at the Construction Instruction Laboratory down in Denver, Colorado. The two main presenters for the video, Gord Cook from Building Knowledge, the founder and one of my partners of Building Knowledge, will be talking about this. And Justin works at CI and is going to be talking through what he's doing in terms of steps for the install of this window and then what the test itself is. So I'll just play the video. I might pause it from time to time to highlight some things, and then we'll talk about it a little bit afterwards. So enjoy.
Okay, here we are at CI Live in Denver, and we're going to be filming the installation of a window in accordance with CSA A440 standard. So thanks very much, but I'll pass it over to Justin Wilson from Construction Instruction to get us started.
Yeah, so step one of this A440-22 install is we're going to have two different variations here. But we're going to do one is, which we're going to say is the minimum base that you see in the standard and some of the critical elements around that. And then we've looked at this and said, okay, if you were to look at a higher weather exposure situation or anything like that, what other things might you consider in addition to that? And just some tricks. And mind you that one of the things we're going to do is we're going to wrap this up, and tomorrow, that's our hope, that we're going to take this outside and run a test on it. So we're going to do an ASTM E331 applied wind and water application test to it and see how our flashing details did here. So we're going to start out. The first component is we've framed this wall. The wall's a 2x6 wall. It has 7/16 OSB installed on it, and we've simply installed 1-inch R5 XPS insulation over the top of that. The next ingredient then is we're going to install the water-resistive barrier layer over the top of this and then complete the window install. We're just going to use a standard flanged window as a key here. Two things that you can have. One is you can have a back dam placed behind the window. So I want to just point that out so that you can actually control the water flow to keep it going this way, and that would actually be sealed in near the back edge of the window as it goes to the interior. But in this particular application, we've actually sloped this sill 8 degrees from back to front, so our pitch is actually outside. So that's one of the other things that's in that standard. So back dam.
Measure 8 degrees on your slope sills? No, sloped is sloped, right? So don't get too hung up on the detail. Just calling that out. Justin's a very technical guy, so that's why he says that.
Or sloped sill. So that piece is there. The others, we're going to make a connection on this side into our air barrier on the interior. So you'll see as we turn this around, there is a vapor retarder installed on the inside. It is sealed all the way around the perimeter of the wall with a double stick type tape, and it's a variable permeance vapor diffusion retarder and air barrier. But we're going to make connections from our inside to our outside as well. So those are just a few of the things to point out. The last thing I want to point out is, depending on your window, it is required that you have adequate structural support right here. And so from sill out. Sometimes if you went with a deeper amount of insulation, you may have your window sitting only on this ledge of foam here. You want to double check with your manufacturer to make sure that they're able with a flange window to call that support all the way around. But if there is needed for sill support here, you may have to adjust your framing, and in some instances we've added a piece of either OSB or 3/4 inch plywood from this area to the outer edge of this foam and secured it back in here and actually to hold and support the sill of the window should that be required by the window manufacturer. So we've already installed to the sides here, so we're going to install the water resistive barrier. The other thing, we've got flashing down at the wall, and the flashing actually, if you look underneath it, is actually connected back with a peel and stick that goes under this flashing right at this level, down, and then extending back under the plate again to actually seal this all the way down to the foundation. So it's going up and extending up both behind the foam and then behind this piece of water table flashing, starter strip for siding and everything. Just keep that in mind. So Sam, we are ready to rock and roll here. We're going to tape and detail it as an air barrier. We're going to start with a small piece on the bottom, attaching with an 1.5 inch pneumatic 18 gauge cap staple. These will be in basically a 16-inch pattern. Pay note that we're going to have a second layer going over here. So I'm going to keep these caps mostly up towards the top. So my second lap then will go over the top of that, and they're not interfering with the taping. So again, we're going to do the base minimum over here, and we're going to base some based on the AMA 100 method A, and AMA is the American Architects and Manufacturers Association. They have a an extreme weather exposure application called method 100-A. We're going to do a couple derivatives on that side of the window to that standard. We're going to come to the top of the wall, minimum 6-inch overlap on our water resistive barrier on the bottom. The other thing is I'm not going to put fasteners within the area that I'm going to tape at the bottom of the wall. I don't want it to interfere with my air barrier detail. The tape doesn't stick as well with that fastener. I'm also not installing them within 6 inches of the window opening because I don't want it to interfere with the flashing tape that I'm going to put on. I'm doing something, if it stays here, let's see. Yep, it's gonna. I'm doing this just for backup here because I'm going through that foam. So a couple different ways. The first is I'm gonna pull down here. I'm gonna leave a scrap of this, I guess no, the window head. Okay, so on this side of the window, before I do this, I'm going to integrate my pan flashing in here as best I can. I'm going to show just a little trick here. But this is actually going to fold in on this side, the standard. So I'm going to do half the window using standard straight flashing tape. It's a little more cost effective. I'm going to show you two different methods.
Key here is it's not a flexible product, so we have to find a way to manage that corner.
So there's my corner problem. Does everybody see that? So I'm going to cut a little butterfly. So now I'm going to have to pull this in. The butterfly is going to have to come out either way. So I had to make a little patch. So I'm going to actually push this into here. As I pull this tape down, put the staples in there so that the WRB material wouldn't roll over as bad when I come to fold it down. That's what I was doing there. I'm going to pull this piece down here, and I'm going to take this over here. And another thing with sloping the sill is I've created this situation right there. It's okay, I just need to do an extra step because the water resistive barrier was buckling back there. I'm going to trim this off and we'll be able to connect back inside. We've got a little discrepancy going on at the window head, and typically we need this head flap up here. So I'm actually going to cut at a 45 for our flashing tape. I'm going to cut this up, this flap here. I will do it up here as long as I'm coming in here. So there's my window head flap. That's a requirement in the standard. I'm just going to fold it up here so it loosely stays out of the way. Okay, so second side, I'm actually going to cut all this off. Now I'm going to try a flexible flashing tape, and I'm going to do it from the inside because you'll see it a little bit better. So I'm going to lay this down and up the wall at 6 inches. Nice thing is it's connecting the sill back to my air barrier. Just want to make sure you lay it down in this corner real well, but it's very fast versus what I had going on the other side. It's just speed, and it's continuous and monolithic product. Okay, and I'm going to pull the second release paper off. Okay, there's that, and what we do is we start in the corner. We work that corner out like this.
Is this familiar?
Just pull it straight down. And spatula.
Use the flexible style sill tape too. Is there some familiarity with that? Yeah, good. So just also highlighting, he's using a pressure scraper instead of a roller, but the point here being that you do need to add that extra pressure in order to make sure that it adheres properly.
Every manufacturer's tape says it's supposed to be adhered. So in fact, we should have been doing and can be doing this
that side
as well.
Too. So now I'm covering that reverse lap. What I'm doing is in this AMA method. So what I'm going to do is connect this WRB to the inside of the building, and the same way that I did there, but I'm going to do it in a way that's air and water tight. See, the question is, if I get water behind the Tyvek and I'm under wind pressure and I'm flashed entirely to that opening, if I get water behind this or air behind this, as I do here, the only thing that's going to stop it is that piece of tape. But I do have water then in this area right here of the window frame. This way, I'm going to terminate it at this blunt edge. This is a little trick, and it's tied in on this side into my interior poly layer as well. So that pretty much sets it up. We'll finish this side off. We've got our head. Sam, I think we're ready for a window. So on the AMA side, typically in this AMA 100 series, one of the things that happens is there's a sealant that's applied to the window flange before the window flange is set to the building. You can install it here on it. I typically do it. I'm going to do it. It's not required on this side here with the 440-22.
And again, an approved caulking, approved by who?
Pointing out that the caulking is an add-on. It's not
Window
a CSA A440.4 requirement. So that's only going on the AMA side
This
and
happens
only
to be
on
a
the top
Quad
and
Max,
sides,
it's
not
Quad
on the
Max
sill.
product, which you guys have a long relationship, Lisa, and they would say, yes, we're good. Notice no caulking on the bottom, that water out.
Okay, now to set the window, we're going to set it properly supported with shim.
This
So
is
then-
flanged window. About half of Canada uses flange, the other half inset.
So again, there's no sealant on this side of the window. Okay, there's sealant on this side from here over here, not on the bottom. We're going to allow drainage there. I'm going to use screws. I'm going to go into the framing. In this case, 1.5 inches. Again, it could be into the side jamb. I'm using screws. Some people use nails. Head flashing would be the option of is that where you integrate now with a head flashing up here prior to flashing the peel and stick flashing being applied?
The manufacturer's tested to a certain structural standard, which includes a certain number of fasteners, and installers would have to match that. And you didn't caulk this side because the A440 standard doesn't require it.
Self-adhered on the bottom. All the control is going to be occurring on the interior of the window. On this side, the minimum would be low expanding window and door foam or backer rod and caulking. We're going to do backer rod and caulk on this side, low expanding window and door foam here. The key is we're going to test this. Let's see how it does. So we're going to do the minimum that we can get away with, that we can do here, and see what that performance is. So the next thing is, in this side, we actually would install then jamb flashing, and then we'll have the head flashing. So those are my next two pieces. Then we'll work on the inside. Typically what we're going to do is, so this is just another butyl rubber tape. I'm going to go at least 1 inch past the window flange. So if you're dealing with cold weather application with any flashing tapes, it's a really good idea to have a manufacturer approved contact cement or adhesive primer. Now that does not give you much repositionability of it, but it will help burn that in and give a second surface to it to actually stick to under cold weather. So when it warms up, it should be. You want to make sure it's approved by the manufacturer though. So the same thing in this corner up here. We're going to fly a minimum 2.5 centimeters, 1 inch past. Roll this right out. And this is required. I'm using it continuous across the top. The 440 standard requires that the head is flashed. So in this side, I will actually take a first piece of tape, seal it here, and we will be dealing with the top of the wall for our test. I'm going to seam tape the other side, same way, and then we're going to come across this bottom, which I did somewhat backwards, just so you know.
One more thing to highlight here is the importance of using the right tape for the right application, right? Not all tapes are created equal. I think we understand that, but it's critical when you're talking about these flashing tapes in these applications that the person installing this doesn't just grab the nearest roll of tuck tape and think the tape is tape and use that for the same applications, right? So approved by the manufacturer for its purpose is something I think we're all familiar with, but really critical in window installation situations.
So you know, the head flap. Should have done this piece first, those second. I technically reverse lapped them, but there's our layup. Now we're ready for the inside. We don't use a J roller, but you can see that this is what I'm using right here. So that's what I did here, but I can also come back. This seam tape doesn't actually require a J roller to it. This tape would. Pretty much all tape need about 30 to 40 pounds of pressure to bed them in. And then we're going to do, this will be our next step, is we're going to do our air barrier detailing, but we'll also then we'll transition to the interior of the window. Overlap the seams 6 inches, tape the seams for best air barrier performance, and we'll deal with these and up here as we get going before we do the test. We're actually going to have to actually seal that all the way back into the top plate, and then these sides need to be taped. But now, we're ready to flip it around and do the interior. So I've got a sloped piece of flashing with the drip edge on it. And it has end dams, as you can see, to keep and direct that water straight off and not allow it to go to the left or the right. And the thing is, the building's not 100% level. Somehow the flashing's not going to be level. If it's either way, it's going to run off. This big flat edge here will retain quite a bit of water under wind load. Now, do I recommend flashing? Would CI recommend flashing? We pretty much always do, and when you test, you can see that makes a very large difference. That flashing, though, would most likely be best served and applied that if I had this piece of head flash here, before I put this flap down, I would have actually put a bead of sealant on the back of this, set it, nailed it, and added an additional piece of flashing tape up here. So I would have cut this head just a little bit deeper, and I've taken another piece of this 4-inch tape and put that over the top of this flashing to stop it. So I've got the ability to stop water from getting in here. I've got the caulk behind the flange, and then I've got this thing to catch it and another piece that's over the top of that. So we're going to pop the brakes and flip this one around.
Yep.
This is the side with the CSA A440.4, and the other side is my AMA 100 modification of the CSA. I'm going to tape this guy back in on my air barrier. This is the variable permeance vapor retarder that we showed before. We've got low expanding window and door foam. I'm going to do on that half of this window over here and down. The other side, I'm going to do a backer rod and caulk application. So I'm going to start right here. Okay, so this side is going to have the foam. So then, on the backer rod side, I'm just going to push this in. The thing is, on your side over here, the CSA 440 on the unmodified side, not good or bad, it's that this, because you didn't do jammed caulk or jam flashing, that is all that's holding out the water. So you got to make a decision like, am I really thinking I'm that confident on that foam curing in that space? It's approved by the window manufacturers, so there's that.
The question is it good enough water? And as Justin mentioned, the window manufacturers are saying they're good with foam. We're suggesting that, boy, if it's the only line of defense, are you sure you're okay? You'll also get conversation about the tapes used on the outside. Can I use a sheathing tape around the window? We're suggesting a true flashing tape as opposed to a simple sheathing tape. But again, that would be up to the, in my opinion, manufacturer to say, am I okay to use a 3-inch wide sheathing tape to seal your windows? And they're going to have comments for you to say, no, we prefer a true flashing tape, 4-inch wide.
So Gord, do you want to summarize?
Yeah, so I'll summarize and say we've shown two different methods here. One that is minimum A440, which is a great start. We're very pleased that there's a new standard, CSA standard for window installation. I think you would agree if you wander around most building sites across the country, you guys here are self-selected high-performance builders. Across the country, this is not what we're seeing. We're seeing no tapes, no caulks, just very simple application. The A440 thinks about slope sill, thinks about sill pan flashing protection, thinks about proper application of fasteners, and we've added a little bit to that on one half of the window.
We'll button this up, and hopefully the weather tomorrow will be like it is, and we'll all go out and look at it and witness it together, and we'll be able to even extract the window together and take it apart and learn something.
I ask window replacement guys all the time, what percentage of windows show signs of moisture damage? And it's always 25, 30, as much as 50% show signs of water damage. Was it enough to rot out the building? Perhaps not. But we know that not all windows leak. We hear a lot of builders are saying, my windows don't leak. How long have you left it? And where do we want to make the responsibility? Especially when we think about resiliency of houses over long term, we really want to get this done. So we said tens of dollars in materials, extra time per window to do that correctly.
This is the test that the window that was just installed will now be subjected to. It's called the ASTM E331 test. And basically, this is a high pressure wind and water test. What's done is a spray rack is set up as a grid on the exterior, and it's sprayed against the building. They'll inject a dye into the water so that any leaks that show up can be traced by color as they disassemble the wall after the test. On the inside of the wall, they actually install a secondary pressure chamber that they depressurize to basically simulate the effects of driven rain, of driven wind pressure on the outside of the building, so that any water finding its way in will then be sucked in. And that's going to highlight the importance of the air barrier continuity as well as the first and second plane of protection continuity on both of these assemblies. So we'll watch them do the test and we'll see what happens. A silver tube is connected to a fan. That's what's going to generate the negative pressure on the inside of the wall. Here's the exterior view, and this is the spray grid. You can see them introducing the pink dye now into the water. And what we don't have on this test working for us here is a first plane of protection. We're really testing the second plane of protection here because there's no siding in place, right? So then they take the wall back inside for deconstruction to see where we spot any leaks and where the weaknesses might be.
Solid install.
And that's the lesson, right? The CSA A440, minimum base, pretty solid, as Justin said. A little bit to water in behind here. A little bit, looks like it's trying to migrate up the head.
Hey Sam, do you want to cut the inside? So that's the foam. You can see how it kind of bubbled all over.
I would be trusting that for
But I'll tell you though,
Look at this right here.
it held the water out.
Yeah, somehow.
I didn't think it was going to hold the water out, but I'm going to say
A little bit here, right, which would seem to
little bit
indicate
here.
at this bottom corner, water running down, so we definitely have some here at the corner.
Yep.
That foam is not really meant as a water seal, it's meant as an air seal, and we use it for water seal, and it seems to do a reasonable job.
When you look at this side where the back rod and caulk is, I've got this airspace right here, right? And so if I got water around my flashing tape, through my sealant, and into the space, I've got a drainway right here. And in a proper sealant joint, you'll do it, it's a fillet bead is what it's called. So the back rod and caulk is not a square chunk. You want your backer rod to be right out towards the edge because you want it to be looking like an hourglass. And that's how you get the best life out of it, because now it can compress and it can extend, and it's got a large bonding area on both of the long ends. And it's pretty, it got a little bit here, you can see the red. So it's dried off. Hey, but you can see the variable permeance vapor retarder, since you've been in the classroom, it's actually done its job, but there's the watermark here. So it's gotten in? It's gotten in to the cavity, but.
Did it come down or did it go up?
It's gotten in here.
So, CSA A440 minimum, small amounts of water under very extreme test, and typically at places where you go, well, that's typical at a corner where it's tougher. And the head flashing, we noticed that head flashing tape was really, really important in this conversation. So you have confidence in the A440, and then you would say, could I add a couple of wrinkles, which is the flex wrap as opposed to the origami?
Maybe throw some side flashing on it. It's one more piece of flashing.
Right.
Right?
So the takeaway is really, I think that that I'd like to emphasize, first and foremost, I think the test is very extreme. And so trace amounts of water on an exposed second plane of protection is a pretty good result. And the takeaway from that is that the ASTM standard that's referenced by the building code, that is the minimum, is a good start. It's really something we can have confidence in. And if you achieve a properly compliant A440.4 install, you're going to have a very high chance of good performance in the install details. There is room to go better and there's room to go best. And some of those additional measures, better products for sill protection, additional quality for the framing protection on the jambs and at the head, and proper order of steps can make that extra bit of difference and give you confidence in the long term. I think we're over time. Thank you so much, everyone. I will say for questions and stuff, if Joe, if you prefer to get down to the showroom, Darrell and I will be around for the next little while at the Build booth. If you want to come and talk to us further about any of the content from today, unless there's any pressing questions from the whole group, I'm going to hand it back over to Joe.
Thank you, Darrell and Mark, for being